Assalamualaikum and hello. In this video, we are going to continue with the example 1 and 2, how to predict the molecular geometry by using Vesper theory. Let's try example 1 first. I got CH2O here. So what to do first, you are going to follow the steps from step 1 until step 5 in order to get the final answer. So let's go one by one. So for the step 1, you have to draw the Lewis structure based on this formula. So how to do it, you get back to your lesson when you learn how to draw the Lewis structure. Calculate the total number of valence electrons first. So I got carbon with 4 valence electrons, and then I got 2 hydrogen atoms. It means 2 valence electrons, and I got 1 oxygen, 6 valence electrons. The total will be 12 of them. So from here, I'm going to determine who's going to be my central atom. It is carbon, because carbon is the most electropositive. So it's going to be in the middle. So C in the middle, and bonded to 1, 2, 3 terminal atoms. I got 2 hydrogens and 1 oxygen. Okay, from here, what happened? I'm going to minus 3 bonding pairs. It means 6 electrons. So minus 6 electrons. I got 6 more left, and this is going to be situated at the terminal atoms, tapi kita ada hydrogen dan oxygen. Hydrogen sudah achieve duplet configuration, so the rest will be at oxygen. So I got 6 dots here. So it means 6 electrons, so no more left. Dan sekarang saya akan double check final one, my central atom carbon. So this carbon ada 6 electrons. So masih belum octet. So what I'm going to do, I'm going to rearrange and replace 1 lone pair from oxygen to make it as double bond. So I'm going to delete this here and gantikan dia dengan double bond. Now my carbon sudah octet with 8 electrons. Kita sudah tentukan Lewis structure. This is our Lewis structure. And what's next? Step number 2. I'm going to identify the types and numbers of electron pairs around the central atom. So maknanya saya akan fokuskan di bahagian carbon. So hanya di bahagian carbon saja yang kita akan lihat. At my central atom, I got how many bonding pairs? So saya ada 1, 2, dan untuk double bond kita kira sebagai 1 bonding pair. So I got 3 bonding pairs total of them. So 3 bonding pair. And then do you have lone pair here? Of course, no. Untuk central atom. So maknanya 0 lone pairs. So bila kita total up 3 tambah 0, kita akan dapat total electron pairs adalah 3. The next one, kita akan go to step 3, predict the arrangement of electron pairs by using Vesper theory. Di sini awak kena letak what is the general formula, basic shape dan molecular shape. This is how you are going to refer to the structure yang awak sudah belajar dalam previous video. So general formula bergantung kepada bilangan bonding pair dan lone pair. So because I got 3 bonding pair sahaja, so it's going to be A, B, 3. So A adalah saya punya central atom, B adalah bilangan bonding pair saya iaitu 3, dan 3 di bawah. So from here, AB3, what is the basic shape? If you refer here at page 3, awak ada total electron pairs adalah 3, bonding pairs adalah 3, lone pair adalah 0, general formula adalah AB3. Our basic shape adalah trigonal planar. Dan molecular geometry is going to be stay the same, trigonal planar. So this is the drawing that you have to draw for the molecular shape with its bond angle. So what will happen? Saya akan tulis jawapan saya berdasarkan reference from that table before. Basic shape adalah trigonal planar. And molecular shape juga namanya stay trigonal planar. Now, I'm going to go to the step number 4. Due to its shape adalah trigonal planar, you have to predict the direction and deviation due to the effect of lone pairs. But right now, in this case, kita tiada lone pairs. That's why drawing and naming for the molecular shape masih kekal based on basic shape. So, I'm going to draw B specific. So, my central adalah carbon, bonded kepada oksigen dan hidrogen. So, pastikan drawing awak masih lagi kekal, cuma bentuk dia sahaja yang berubah seperti segitiga. And then, your lone pair at oksigen. And from here, this is the trigonal planar. Dan pastikan awak tidak lupa tentang bond angle. So, I take it from here to there. This is going to be 120 degree. So this is how you want to answer the question when it asks you to predict the molecular geometry by using Vesper theory. Dan saya sudah ajar based on CH2O. So di mana markah awak? The first mark is going to be here for your Lewis structure. And the second mark is going to be from here to here. The third mark adalah bahagian sini. And the fourth mark adalah the drawing for molecular shape, and the last one adalah bond angle. Pastikan awak dapat full 5 marks. Now we go to the second example, iaitu saya ada NF3. Konsep yang sama, we draw the Lewis structure first. So, let's calculate the Lewis structure. For nitrogen, we got 5 valence electrons. For 3 fluorine, we got 3 times 7 valence electrons. Total dia adalah 21 electrons. And total for everything adalah 26 electrons. And who is going to be our central? Nitrogen is the most electropositive. So, dia akan jadi central. So, I draw nitrogen in the middle, bonded kepada 3 fluorine atoms. So, I use up 3 bonding pairs, maknanya 6 electrons. So, minus 6 electrons. Kita ada 20 electrons left over untuk letak di bahagian terminal atom. So, each of them akan dapat 6. 2, 4, 6, 8, 10, 12, 14, 16, 18. So, 18 of them. So, 20 minus 18. Awak ada baki 2 electrons. So, 2 lagi ni kita akan letak di bahagian central. And the leftover adalah 0. So, from here, last step, pastikan central atom awak nitrogen sudah balance. So, we got 2, 2, 2, 2, 8 electrons. So, maknanya sudah balance. Dan kiraan kita pun dapat kosong final one. So, this is the Lewis structure for NF3. But right now, we are going to focus at the central atom, iaitu nitrogen. For nitrogen, we got 3 bonding pairs. So, the answer will be 3. And then you got 1 lone pair here. So, 1. And the total electron pairs adalah 3 tambah 1, you will get 4. So, bila 4, awak akan fokus dekat bahagian 4. Iaitu total electron pairs 4. Dan general formula dia akan bergantung kepada bonding pair dan juga lone pair. So, my general formula is going to be A for central and B for bonding pairs. You got 3 and E for 1 lone pair. So, this is going to be A, B, 3, E. Kerana total electron pairs dia adalah 4, kita akan fokus kepada table kita. As you see here, total electron pairs masih lagi 4. And then you got 3 bonding pairs and 1 lone pair. Basic shape masih lagi tetrahedral, tetapi molecular shape adalah trigonal pyramidal. So, kita akan draw based on this drawing with its bond angle. So, my answer here is going to be basic shape tetrahedral. Pastikan spelling betul. And then molecular shape adalah trigonal pyramidal. And now, I'm going to predict the shape for molecular geometry. Dan kerana effect of lone pairs di bahagian sini, so drawing awak akan jadi different based on trigonal pyramidal. So macam mana kita akan draw? Kita akan letak nitrogen as our central. And then, kita ada 1, 2 dan yang ketiga a bit slanted. And I will put fluorine, my terminal atoms, di bahagian situ. Dan seterusnya kita fill in the lone pairs around central atoms dan juga terminal atoms. Dan pastikan semuanya complete and you will get this drawing. So this is trigonal pyramidal. And jangan lupa, last one, you have to label the bond angle. In this case, bond angle is going to be from here to here less than 109.5 degree. And this is the drawing of an F3 when you want to predict the molecular geometry by using Vesper theory. So the concept is just the same, cuma dia punya bilangan bonding pair dengan lone pair tu berubah berdasarkan species yang awak dapat. So pastikan the most basic one, you know how to draw the Lewis structure. And from there, you determine the correct numbers of bonding pairs and lone pairs. And of course, you will get the correct drawing at the end for the molecular shape. So how to get the marks for this one? First mark is going to be your Lewis structure. And second mark from here to here. The third mark from here to here. And fourth mark adalah your molecular shape. Dan last one adalah bond angle. As usual, make sure you got full 5 marks. Saya harap berdasarkan 2 examples here, you understand how to determine and predict the shape for molecular geometry of any molecules yang awak dapat in the future. I hope you clear so far with subtopic 7.2. I leave try this 7.0 for your exercise to enhance your understanding about this topic. Please try to do this, and if you want the final answer, you can ask me. That's all for this video. Thanks for watching. Bye!